Hi friends, welcome to QuicklyEmbedded session on Bluetooth Low Energy. This video gives you BLE technology overview and introduction. We describe the key points that you need to be aware on Bluetooth Low Energy that lays foundation for Internet of Things. Let's understand why BLE is a smart thing in everything. You can get to know all about BLE at one place, that's here. Like history of BLE, basic of BLE, specifications, where is BLE used most, applications, etc. For more and more useful training on embedded technologies and to learn these technologies quickly, subscribe to our YouTube channel QuicklyEmbedded. Let's get started. BLE or Bluetooth Low Energy, formerly known as BT Smart, is an universal low-power wireless standard used for exchanging data over short distances from fixed and mobile devices like smartphone or tablet. BLE was designed for devices that do not stream data continuously but instead transfer small packets of data as needed. The BLE is intended to provide considerably low power consumption, that is, it is less power hungry and low cost of course, while maintaining a similar communication range as that of BT Classic. In BT Classic, the short wavelength radio transmission is in the ISM band, that is 2.402 GHz to 2.480 GHz. BLE also uses the same spectrum range as that of BT Classic, but BLE uses a different set of channels. That is, instead of classic Bluetooth 79 channels of 1 MHz, BLE has 40 channels of 2 MHz. BLE also is a foundation for the IoT and applications that can scale with the market and provide developers the flexibility to innovate and be the foundation for the IoT. One of the new profile shipping with 4.2 spec is that known as IPSP, and that enables IPv6 for Bluetooth. As for privacy, Bluetooth beacons would need permission to connect to a track your device. It would need permission to really connect and track your device. BTSig defines several profiles, spec for how a device works in a particular application. For low energy devices, manufacturers are expected to implement the appropriate spec for their device in order to ensure compatibility. Okay, let's talk about Bluetooth Low Energy specs and the versions. BT 4.0 was released in 2010, BLE introduced in 2011. So BLE was a subset of version 4.0 spec in 2011 with an entirely new protocol stack for rapid build-up of simple link aimed at very low power applications running off a coin cell, designed to be lowest cost and easy to implement. The BT 4.0 supports two modes, single mode and dual mode. Single mode devices that only support low energy but not classic Bluetooth radio. Right? So the single mode BT 4.0 devices that only support low energy but not classic Bluetooth. But in dual mode you support both, that is devices that support both low energy as well as classic BT radio, that is dual mode BT 4.0. The Bluetooth SIG recommends implementing new spec in all new designs and requires the same qualification process as all other Bluetooth designs. Devices using Bluetooth Smart will be backward compatible with earlier versions of BT and also implement the low energy features. Let's see more about BLE 4.2 spec. With BLE 4.2 Bluetooth Smart sensors, transmit data over the internet because it supports low power IPv6 protocol. This advantage of 4.2 or Bluetooth 4.1 is very important because it's allowing chips to use Bluetooth over Internet Protocol version 6 IPv6 for direct internet access. With new and more power efficient and highly secure features, BLE 4.2 provides additional benefits, allowing only trusted owners to track device location and confidently pair devices. Speed is 250% faster. Note, 250% faster than earlier version. 10x more capacity compared to previous version. So meaning BLE 4.2 enables 250% faster and more reliable over-the-air data transmission and 10x more packet capacity. BLE 5.0 spec is out in 2016 December. We'll talk a bit about BT 5.0 at the end of this video. So as I already mentioned, the Bluetooth low energy is designed such a way that the BT device can run from a coin cell. Consumes very less power. The range is typically around 150 meters in open field, and BLE offers a range up to 300 meters with a 10 dBm radio chipset. That's a BLE maximum, 10 dBm radio chipset, 300 meters. Latency 3 milliseconds, it's very good. Modulation GFSK, Gaussian frequency shift keying at 2.4 GHz band. However, BLE uses modulation index of 0.5 compared to BT Classic uses 0.35. So BLE uses modulation index of 0.5. Data rate, BLE can work up to 1 megabits per second. Application data throughput is 0.27 megabits per second. So BLE is not really about data throughput, it's really about transferring state using very less power with lowest latency. So the sleep current in BLE is to 1 microamps, consumes very less. And let's talk about communications. A BLE device can accommodate with the outside world in two ways: broadcasting or connections. Broadcasting, using connectionless broadcasting, you can send data out to a scanning device or receiver in listening range. Right, that's broadcasting. But in connections, if you need to transmit data in both directions, or if you have more data than the two advertising payloads can accommodate, you will need a connection. So connection is a permanent periodical data exchange of packets between two devices. Power, TX power, the recent changes in Bluetooth and regulatory standards allow low energy Bluetooth devices to transmit up to 100 milliwatts, 20 dBm transmit power. Receive sensitivity 70 dBm, and the bit error rate is 0.1%. The bit error rate, BER, is the number of bit errors per unit time. The bit error ratio, also BER, is the number of bit errors divided by the total number of transmitted bits during a steady time interval. So BER is nothing but the number of bit errors divided by total number of transmitted bits. Let's see about profiles. In Bluetooth low energy, profiles expose the state of a device. Say ATT, attribute protocol, GATT, generic attribute profile, generic access protocol, GAP, 6 low WPAN, that is IPv6 or low power wireless personal area network. So talking about GAP, Generic Access Protocol, this profile defines the generic procedures related to device discovery and link management when connecting to Bluetooth devices. That is GAP, Generic Access Protocol. GATT, Generic Attribute Protocol, provides profile and service discovery for BLE. The described procedures show how to use ATT, Attribute Protocol, for service discovery, as well as how to read and write attributes, that is nothing but data. Services and profiles are developed on top of GATT, right? And 6 allow WPAN, the IPv6 over low power wireless personal area networks. An alternative to GATT is to use TCP/IP based communication with 6 allowed WPAN. This technology can be used to compress the IP messages sent over BLE to save on size requirement and power consumption. So this is a little bit about the profile supported in BLE. Let's see some of the targeted applications of BLE. It is used in phone accessories, sports and fitness, health, wellness tracking, M2M internet connected devices, home building automation products, smart energy meters and displays, animal tagging, intelligent tagging systems, and automotive. The list goes on. Every day you find some new application where you can use BLE. BLE is well suited for smart gadgets, sensors, actuators, and any device that requires very low power to function. That is power-friendly devices. For instance, an array of temperature or moisture sensors could monitor the state of the soil in a greenhouse, providing data that triggers irrigation and ventilation systems. Remember, total addressable market of BLE-based product is in billions of dollars. So one of the reasons why you need to know about BLE from this video, and also try out some BLE applications after you understand the basics of BLE here. Right? So BLE is an always off technology, that is, it transmits short packages of data and is not able to support audio streaming. Remember, it doesn't support audio streaming. And is perfect for devices like heart rate belt, mouse or keypad. So BLE has a data rate of 1 megabits per second, but it is not optimized for file transfer purposes. BLE is designed for sending small chunks of data, that is exposing the state. It's good for small discrete data transfers. Data can be read at any time by client, right? And very suitable for Internet of Things. Let's see why we should really design with BLE, right? So there are many reasons. So a new feature BLE adds compared to classic Bluetooth technology is advertising functionality. With this feature, a device acting as a slave can announce that it has something to transmit to the master. An advertisement message can also include an event or a measurement value. So the two other family industry standards for short hop RF connectivity are ZigBee and Wi-Fi. Both have a strong appeal to different applications. ZigBee provides a flexible mesh networking architecture, ideal for complex and multi-node networks, and Wi-Fi supports very high data rates. But neither can match the low-cost simplicity and ultra-low power consumption of Bluetooth LE, an application that transmits small amounts of data. The simple start topology reduces implementation of complexity significantly in BLE, and it's very robust. A frequency hopping scheme makes a BLE highly resistant to interference at its 2.4 GHz license-free band. And BLE, low power consumption, very secure. So through optional 128-bit AES encryption, Its BLE is known for it's widely secured protocol to use in your devices. BLE technology uses the same adaptive frequency hopping AFH technology as classic Bluetooth technology. So this AFH feature enables BLE to achieve robust transmission in a noisy RF environment found in the home or industrial or medical application. So BLE can coexist with other wireless technologies, classic Bluetooth, wireless LAN, IEEE 802.15.4, that is ZigBee, and several proprietary radio that uses license-free ISM band 2.4 GHz. As both classic Bluetooth technology and BLE technology utilize AFH, which minimize interference, as we already understood. So it minimizes interference with other radio technology. So Bluetooth transmission is very robust and reliable. And it supports for gateway. So a gateway is any system that can connect BLE device and a wide area network can serve as gateway. So home PC can see devices around your home. Your smart home can see all devices around you. The simplicity of GATT servers makes it easy to represent those devices over the web. BLE allows generic gateways such as mobile phones. These allow devices to connect out of the box. Enables any device to connect to the web via a handset. So easy it is. So there's a lot of advantages why you should really design with BLE. Let's compare BT Classic with BT BLE. It's a topology. Most off-the-shelf BLE chipsets have Bluetooth 4.0 compliant firmware implementation. However, version 4.0 has a topology limitation towards peer-to-peer mesh networks. The supported topology called Piconet, which enables a master node of one or several slaves nodes to simultaneously be a slave of another node. The scatternet absolutely makes the multi-hop connection possible. Let's compare the distance and the range. When developing a Bluetooth device, you can give your device a better range by selecting Bluetooth chip with best receiver sensitivity and output power, and making sure that you use a good antenna. So you're likely to run into a situation where you want to handle hundreds of even thousands of Bluetooth devices in a relatively small area, such as an office building. For this, you need to use mesh network to connect the gateway and local Bluetooth devices. So BT Classic had a typical range of 100 meters, around 330 feet, but BTLE can go beyond 100 meters. Over the air data rate, in BT Classic it was 1 to 3 megabits per second, but BTLE application needs 1 megabits per second. It's a big support, so it doesn't need really more than that. The bandwidth 1 megahertz in BT Classic but 2 megahertz in BTLE. Application throughput 0.7 to 2.1 megabits per second in Classic, but in BLE 0.27 megabits per second. Latency typically 100 milliseconds in Classic but 6 milliseconds in BLE. So 100 milliseconds in Classic but 6 milliseconds in BLE. Security, BT Classic supports 56 or 128 bit and app layer defined, but the BLE 128 bit AES with counter mode. So these are some of the comparison of BT Classic and BLE that you need to be aware of. So what's more can you know about BLE? If you see a Bluetooth Smart Ready logo, those are the products which implement both the classic and low energy elements of the versions for spec. So they are designated as Bluetooth Smart Ready products. Okay, the next thing, let's touch upon a little bit on BT 5.0. I'll try to cover more details in a different video. But Bluetooth 5.0 standard is planned to introduce additional improvements for increased data throughput, improved sensitivity, and longer range connections. So you're getting more than the previous spec. So 5.0 BLE will permit audio, voice, certainly data, most features that generic Bluetooth or PR EDR is capable of now. Bluetooth 5 will offer 4 times the range of its predecessors. Bluetooth 5 will feature twice the transmission speed of Bluetooth 4.2. Bluetooth 5 will showcase an 800% increase in data broadcasting capacity. 800% increase. Bluetooth 5 will offer new functionalities for connectionless devices and services. These will mostly be related to location information and navigation. Better for beacons that beam location data or advertisements to your phone as you wander on malls, airports, and other public spaces. So you need to be aware of Bluetooth 5.0 spec, and then you can understand more in my next video on Bluetooth 5.0. Well, you learned a lot about Bluetooth low energy spec, applications, and details. And if you want to learn a lot more embedded concepts quickly and easily, subscribe, like us on YouTube, QuicklyEmbedded channel, and keep coming back to the channel and get to know easily a lot of embedded stuff here. Have a good day.